A very good morning, friends. Today we'll continue lecture number 5 on permutation and combination. So basically this lecture is on permutation part, that is arrangement. So let us start lecture number 5, permutation and combination. First important thing is what? What is definition of permutation? Let n objects are given out of which any r objects can be arranged in NPR ways. This arrangement is called what? Which is called permutation. This arrangement is called permutation of R objects taken from given n objects. And is defined as NPR is what? N factor upon n minus r factorial. In this case, order of arranged elements are important. In which order you are arranging elements is important. For example, on two chairs you are arranging two persons. Ramesh will be on left side, Suresh will be on right side, or Suresh is on left side, Ramesh is on right side. So it will give you two different arrangements. Whereas in selection, either I select Ramesh first or Suresh later on, or Suresh first, Ramesh later on, will not make any difference. So in selection, order is not playing important role, whereas in arrangement it plays important role. Let me explain the formula, how this formula has come. Explanation of formula. See, out of n persons we are arranging r person. 1, 2, 3, 4. This is earth. This is first, second, third, fourth, and this is earth. So we have to arrange r persons out of n persons. So at first place, how many arrangements will be possible? I can arrange n persons on first chair. In how many ways I can do this? N ways. After arranging first person, how many persons left now? N minus 1 persons. So second person can be arranged in n out of n minus 1 persons in n minus 1 ways. Same with third person out of remaining n minus 2. Fourth person out of remaining n minus 3. See, fourth person n minus 3. That means number of subtracted number is what? 1 less than the particular position. So here rth person n minus r minus 1. Multiply them, that will give you total number of arrangements of r persons out of n persons. This is our answer. But I have to convert this in factorial notation, so I have to multiply some more. So n into n minus 1 into n minus 2 into n minus 3. If you simplify, you will get n minus r plus 1. Now we will multiply some more. So whatever extra I will multiply, so much I will divide. After n minus r plus 1, n minus r, n minus r minus 1, and so on, 3 into 2 into 1. So whatever extra I have multiplied, same thing I will divide. N minus r, n minus r minus 1, 3 into 2 into 1. This is n to 1 is what? N factor upon n minus r to 1 is what? N minus r factorial. So this is the formula of permutation. Now let me explain some practical explanation how it is happening. Suppose two persons are there, A and B. इनमें से किसी एक को अरेंज कर रहा हूं. I can arrange A can go, I can arrange B. So practically you are observing two ways. By formula, out of two person, arranging one person, that is 2p1, and 2p1 is what? 2 factor upon 2 minus 1 factorial 2 upon 2 ways. Suppose I have to arrange both on two different chairs. One arrangement is what? AB, or second arrangement is what? BA. This is what you are observing practically. By formula, it is what? Out of two persons, we are arranging two persons, 2p2, which is 2 factor upon 2 minus 2 is what? 2 factor is what? 2 upon 0 factorial, and the value of 0 factor is what? 1. Two ways. Let me take second example. 3 persons are there, A, B, C. इसमें से हमको एक को अरेंज करना है ऑन वन चेयर. I can arrange A, or I can arrange B, or I can arrange C. Three ways. By formula 3p1, 3 factor upon 3 minus 1 factorial, 3 factor upon 2 factorial, 3 ways. सपोज हमको दो को अरेंज करना है, तो सबसे पहले हम सिलेक्ट करेंगे किन दो को अरेंज कर रहे हैं. तो दे कैन बी ए, बी, और बी सी, और ए सी. AB on two chairs can be arranged as ABBA, or BC can be arranged in BCCB, or means add AC can be arranged in ACCA. 2 plus 2 plus 2, 6 ways. By formula, out of 3 persons, 2 persons can be arranged in 3p2. 3 factor upon 3 minus 2 is what? 1 factorial. 6 ways. Suppose हमको तीनों को अरेंज करना है, तो प्रैक्टिकली इट इज व्हाट? ABC, ACB, BAC, BCA, CAB, CBA. That is total 6 ways. By formula, out of 3 persons, all 3 persons can be arranged in 3p3. 3 factor upon 3 minus 3. 3 factor upon 0 factorial. Practically also 6 ways, and by formula also you are observing 6 ways, and so on. So let us solve some problems on permutation. Find n if np6 is to np3 is equal to 120 is to 1. Since np6 is to np3, 120 is to np6 is what? N factor upon n minus 6 factorial. Ratio means division. N factor upon n minus 3 factorial. is equal to 120. Multiplied by n minus 3 factor upon now n factor will get cancelled. This n minus 3 factor can be written as n minus 3, n minus 4, n minus 5 into n minus 6 onwards we'll write n minus 6 factorial upon so this will give you n minus 3, n minus 4. So these are three consecutive descending order factors. So 120 can be written as 6 into 5 into 4. On equating we get n minus 3 is 6, n is 9. Next is find m and n. If n plus n p2 is equal to 56 and m minus n p2 is what, 12. M plus n p2 m minus n p2 by definition is what, n plus n factorial upon n plus n minus 2 factorial and m minus n factorial upon m minus n minus 2 is equal to 12. M plus n into 1 less n plus n minus 1 into 1 more less factorial divided by n plus n minus 2 factorial and m minus n m minus n minus 1 into factorial divided by 12. So this will be n plus n into n plus n minus 1. So these are two consecutive descending order. 56 can be written as 8 into 7, two consecutive descending order, and m minus n into m minus 1 is equal to 12 can be written as 4 into 3. On equating we get n plus n is what, 8, and m minus n is what, 4. On solving we get, when we add 2n is what, 12, so n is what, 6, and n is what, 6 plus n is 8, so n is what, 2. 12 PR minus 2 is to 11 PR minus 1 is equal to 3 is to 14. 12P three is to 14. 12 factorial upon 12 minus R minus 2 is what? 14 minus R divided by 11 factor upon 11 minus R, so 12 minus R, 3 upon 14. 12 can be written as 12 into 11 factorial, and 14 minus R can be written as 14 minus R, 1 less, 13 minus R, 1 more less, 12 minus R factorial into 12 minus R factorial upon 3 by 14. 12 minus R factorial, n factorial cancel, 12 upon 14 minus R into 3 by 14. 12 and 3 will get cancelled, wait for here, 14 for the 56, cross multiply, 14 minus R into 56 can be written as 8 into 7. On equating we get 8 is equal to 14 minus R. R is equal to 14 minus 8. R is equal to 6. Show that n plus 1 into NPR is equal to n minus R plus 1 into n plus 1 PR. We'll start with our RHS. N minus R plus 1 into n minus R plus 1 into n plus 1 factorial divided by n plus 1 minus R factorial. N minus R plus 1. How will write n plus 1 factorial? N plus 1 into 1 less n factorial. And how will write n plus 1 minus R factorial? N plus 1 minus R into 1 less n minus R factorial. Now n minus R plus 1 will get cancelled. What is left? N plus 1 into n factor upon n minus R factorial. This n plus 1 you keep as it is. What is n factor upon n minus R factorial? NPR. And this is nothing but your left hand side. Therefore, How many four-letter words can be formed using letters in the word Madhuri? If number one, letters can be repeated, number two, letters cannot be repeated. The word Madhuri contains seven letters. We are forming word of four letters. Case 1. Repetition of letter is allowed. Letters can be repeated. In this case, we can form word of four letters in. See, this first letter can be arranged in 7p1 and means multiply. Second letter can be arranged in 7p1. Third letter can be arranged in 7p1 and fourth letter can be arranged in 7p1, which is what? 7 into 7 into 7 into 7. 49 into 49, 2401. Second case is letters cannot be repeated. In this case, word of four letters can be formed in 7p4, 7 factor upon 7 minus 4 is what? 3 factorial. 7654, 3 factor upon 42 into 20, 840 words. Determine the number of arrangements of letters of algorithm. This is last. The word algorithm contains contains 9 letters. In which A, O, I, in which 3 are vowels and 4 are consonants. First case is what? Vowels are always together. Since we are arranging vowels together, therefore we will take them in one group. So one group plus 6 consonants is equal to 7 at 7 different places in a row can be arranged in seven P7, 7 factorial, 5040 ways. The group of three vowels among themselves can be arranged in 3P3, 3 factorial is equal to 6 ways. Therefore, total number of arrangements is equal to 5040 into 6, 30,240 ways. No two vowels are together. Case 2 is what? No two vowels are together. So first we'll arrange consonants. 6 consonants at 6 different places. At 6 different places in a row can be arranged in 6p6, 6 factorial, 720 ways. लिया है, हो सकता है. See, this is one arrangement of consonants. See, for vowel we will have 1, 2, 3, 4, 5, 6, 7 ways. From above it is clear that for 6 vowels, 3 vowels, there are 7 possible places. यानी कंसोनेंट्स पे रिस्ट्रिक्शन नहीं है, उससे एक ज्यादा प्लेस आता है वॉवल्स के लिए. 3 vowels, there are 7 possible places at which no 2 vowels are together. They can be arranged in 7p3, 7 factor upon 7 minus 3 is what? 4 factorial, 7 into 6 into 5, 210 ways. Therefore, total number of arrangements in which no 2 vowels are together is equal to 720 into 210 1,51,200 ways. Consonants are at even places. Out of 9 places, because 9 letters are there, we will arrange them, 9 places will be there. Out of 9 places, second, fourth, sixth and eighth are 4 even places. Therefore, 6 consonants at 4 even places can be arranged in 6p4, 6 factor upon 6 minus 4 is what? 2 factorial, which is 720 upon 2 is equal to 360 ways. So we have arranged only 4 letters at 4 places. Remaining 5 letters at remaining 5 places can be arranged in 5p5, 5 factorial, 120 ways. So total number of arrangement will be 360 into 120. $43,200 ways. Next is A is the first and T is the last. Case 4. A is the first and T is last. O in beginning can be arranged in one way. T at end can be arranged in one way. एक एक तरीके से हमने O और T को अरेंज कर लिया. रिमेनिंग 7 letters in between them can be arranged in seven P7, 7 factors equal to 5040 ways. Therefore, total number of arrangements is equal to 1 into 5040 into 1. Yes. Thank you so much. Today's quote is what? कोई नामुमकिन चीज को मुमकिन करके दिखा, लोगों से थोड़ा हट करके दिखा, भीड़ से तू अलग चलकर दिखा, जमाना खुद ब खुद तुझे पहचान लेगा. थैंक यू. बहुत सुंदर कोट है और इस पे अमल करके दिखाइए.